Okay, so because I got cut off in the previous video, I'll go ahead and just finish it on this second one. So this is still part of the second video for the atomic structure. So here's the Bohr atom model. And each one of these rings represents an energy level. I'm going to show you that there are 7 energy levels that correspond to the 7 rows on the periodic table. So you can find the electrons for the first row in this first energy level, the second row in the second energy level, the third row in the third energy level, and so on and so forth. The cool thing is these electrons, as I've told you, they can absorb energy. So the electrons can absorb energy, but when they fall back down to their ground states or to their original states, they are going to lose energy in the form of light. So they will give off light. So electrons exist in these fixed energy levels surrounding the nucleus. We say that as quantization of energy, meaning they get quantized, so they can move out to higher energy levels. The promotion is them going to their excited state, and then they can fall back down. Energy is released as the electron travels back to the lower levels to its relaxation state. So you will see down here at the bottom it says energy level 1, energy level 2, energy level 3. It says n equals 1, n equals 2, n equals 3. So n is the energy level. And 1 is which orbit it's in. So we're going to go through some practice of that in class. So the amount of energy, absorbed in jumping from one energy level to another is going to be, or to higher, it's a precise quantity. It's a very specific amount. So it takes a very specific quanta of energy to get that electron to move. If you give it too little, it's not going to be able to move. So what we call the orbit is, that's what Bohr called those fixed energy levels, so they can move between those fixed energy levels. They are specific distances from the nucleus. N equals 1 is closer than n equals 2. And that still holds true a little bit today, but you're going to see that the electrons don't orbit in these, perfect planetary orbits that Bohr thought. The ground state is the lowest possible energy state. So Bohr's theory, the electrons are found only in these allowed energy levels, and we now know that's not the case. The allowed levels are quantized energy levels or orbits, meaning that they're a specific distance from the nucleus. So atoms can absorb energy or they can release energy, which we know that today, so they can go to higher energy levels and then fall back down. And the energy differences may be calculated from the wavelength of light emitted. So you can actually tell the distance that that electron moved by calculating the wavelength of the light that comes out. And that's where the spectral lines come from. The spectral lines are the result of electron transitions between those energy levels. So as the electrons give off light, and if you pass that light through a prism, they're going to produce these very specific spectral lines. These correlate to specific distances that those electrons moved. So if the electrons moved in this distance, they would produce that color of light. If they moved this distance, if the wavelength that comes off corresponds to that, they'll produce that color of light. So each element produces its own line spectrum. This is how we can identify the elements that are present on stars, by taking starlight and passing it through a prism, and then you can tell what elements are present there. So that's kind of the definition of the Bohr atom or the Bohr theory, that the electrons are in these kind of planetary orbits. And we now know that to not be 100% true. Bohr's model of the atom failed to explain line spectra of atoms with more than one electron. So really, when you get outside of hydrogen, they don't really follow the specific rules that we would have expected for Bohr's model. So one major change from Bohr's model is that electrons do not move in these orbits. They don't move in these planetary orbits around the nucleus. They move in orbitals, which are regions in space with a high probability of finding an electron. And that's what you saw me draw the other day on the board when I drew the S, P, and the D orbitals. Some of them are circular shaped, some of them are dumbbell shaped, some of them are four-leaf clover shaped. So these orbitals are where the electrons are going to move in, and they are specific distances from the nucleus, but they're more of a region where that electron can travel in rather than being a specific circular movement. So the electrons move rapidly within the orbital, giving it that kind of electron cloud look. And that's where we're going to stop at. So we will, I will give you some drawings of all of these different structures of the atom, kind of the different models of the atom up to our current model today. And so you can go ahead and record those in your notes as we go through those in class.